So now we want to look at what we call the put-call parity theorem. Put-call parity theorem. Now, the put-call parity theorem is just a theorem which try to moderate the value of the put and the value of the call, so that they can eliminate what we call the arbitrage opportunities. So let's go at page 2. Page 2 there. So Monu, I can see you have a question. Eh? You want me to explain about the last one I've said about the exercising a put. What have I said? I can't remember. We have said that whenever you see that for the put option, you are having a positive, that means you are in the money. That means as a seller, that's when you should exercise your option. If you get a 0, that means you are not gaining, you are not losing, you should not exercise. When you get out of the money, that means they are negative. That means you definitely should not exercise that option. For the call option, remember it's giving the buyer the right. Eh? So in that case, if you're in the money, where they have the in the money, that's when you should sell as a buyer. When it's at the money, 50-50, that's what we call the point of indifference. When you are having a negative, kind of don't exercise that. Eh? You only exercise in market or in business. You only exercise mostly when you just are having a profit. Yeah, that's the motive of the business. So now let's go back to the put-call parity theorem. Put-call parity theorem. So under this theorem, it's a theorem which tries to link the price of the call and the put. So I repeat again, it tries to link the price of the call and the put option to determine the price of the call and the put in a manner that arbitrage opportunities are eliminated. So that's all about the put-call parity theorem. It's try to bring together, to moderate the value of the call and the value of the put, in that the arbitrage opportunities can be eliminated. And how do we get the value of the put? Under the put-call parity theorem, this is how we get the value of the put. The value of the put, the value of the put, the value of the put. So in this case, you'll take the value of the call, the value of the call, then you deduct PA plus A, RT. Now that's the formula. That's the formula. Where what's P, what's C, what's PA, what's E, what's that small e, what's R, what's T. You know, to get this credential well, P just means the value of the put. Value of the put. Now this is under the put-call parity theorem. When you have you want the value of the put or the value of the call, and in this case, you want to eliminate all the arbitrage opportunities. So this is the value of the put. C, this just means the value of the call. PA, that means the market price per share, or sometimes it can be noted by S, that means the spot rate. Then we have E, that means the exercise, or what we call the strike price. We have said that the exercise price is the amount you get when you sell or when you buy. That's what we call the exercise. Anything different from the market price, that's what we call the exercise price. Then we have E. E means exponential constant. Take out your calculator. Take out your calculator. And it's always 2.7183. If you take your calculator, if you don't have a calculator, let me show you how to get it. This is how you get it. This is how you get it. You just press shift. You can see where shift is. And then we have this natural log, this in. So it just shift in. You'll see just that small e. Then you can press 1 equals, you'll get 2.718. So you press shift and then in. This in, there up you'll see an e, an exponential. And that's how we get that. Then we have R. R means the risk-free rate. Risk-free rate. And then we have T. T is the time to maturity. Time to maturity, and note that it should always be in years. Time to maturity in years. That means if you're told that the time to maturity is 3 months, so in this case you have to convert them into year. So in that case you can take 3/12, which you get 0.25. Now that's what you call the put call parity theorem formula. We'll come back to that. So you need to get those credentials. P, what's C, what's PA, what's E, what's this big E, small e, R, and T. Now let's go to another important aspect of how do we value option pricing models. Let's go to option pricing models. Option pricing models. So in this case, we have two methods or two models you can use. We have two models you can use. Number one, we have what we call the binomial. We have the binomial. Then number two, we have what we call the Brack and scores. So I want to start with this one. This is a majorly tested area, Brack and score model. And at a Brack and score model, this model is used to derive the fair value of the core option. How? It's used where the share price at the end of the period can take a continuous value. Can take a continuous value. So that's at the Brack and score. We'll come back to note to another method known as the binomial model. Binomial model, it assumes that the model is based on the assumption that there are only two prices that will emerge at the end. That's binomial. But a Brack and score, it assumes that the share price at the date of expiry can take a continuous value. So then we have the assumptions of Brack and score. So some of these assumption is that the rate of return in the share follows a normal distribution. So I hope we had already indicated that you need to have a normal distribution table. That's one of the important assumption. Also, it assumes that the risk-free rate is constant. Also, number four, the option is an European option. Then there are no restrictions, the share price is continuous, then it assumes there is no dividend payment. So according to Brack and score, how do we get the value of the share? How do we get the value of the share? So we'll come back to that. So we are looking at Brack and score. That's one of the model, option pricing model. Now that's the method we are looking. How do we get Brack and score? So in this case, this is how we get the value of the call. The value of the call using Brack and score, you will take what you call PND1, then you deduct the exercise price, you divide by exponential raised power RT, then ND2. That's the formula. The value of the call, that's the formula. Now, another problem arises. How do we get D1? This is how we get the D1. D1, you take natural log P over E plus the risk-free rate plus a half standard deviation square, that's the variance, then you multiply by T. All of it you divide by standard deviation square root of T. That's how we get D1. How do we get D2? D2, you take D1 minus standard deviation square root of T. So that's the formula. So now let me explain those credentials. So VP, that means the value of the call. P just means the market price per share or the spot rate. Sometimes it can be denoted using an S. Then D1 or N. N is what we call a normal distribution. We'll come back to normal distribution. Let me take you back to normal distribution. That's what we call normal distribution. E, that's the exercise price, exponential constant, risk-free rate, time remaining to maturity. Normal distribution and the D2. So that's D2. Then D1, we have said you take the natural log. Using a calculator, this is how you get the natural log. Natural log. This was natural log. Natural log. Then market price per share, exercise price, risk-free rate, a half, standard deviation square. This one you get a variance. Yeah, so it may say this one is the standard deviation, or what we call volatility. So volatility means standard deviation. Now, if you square, you just get the variance. Then you divide by the standard deviation, you multiply by the square root of t. We have said that t is the time remaining to maturity. And D2, you get D1 minus standard deviation over square root of t. So that means if you get D1 wrong, your D2 is wrong. That means the value of the call is wrong.